All right, today's lesson is on 6-2, angles and the unit circle. An angle is the rotation of a ray. Now remember, a ray has a point and then an arrow from its initial side to its terminal side. Now, basically, this is going to be your y-axis, this is your x-axis. Now, you are always going to start off on the x-axis. This is called the initial side right here. That is called the initial side. The terminal side is where it's going to end. So let's say it ends somewhere right here. This is called the terminal side. This is going to be our theta. Now, this is called standard position. This is in standard position. It is standard position because we are traveling counterclockwise. So keep that in mind. Standard position is counterclockwise from the x-axis. Because we will be going clockwise, which will be a negative direction. Now, when we're looking at our unit circle, let's write some facts regarding our quadrants. Keep in mind, this is my x-axis, this is my y-axis. This is quadrant 1. In quadrant 1, the x is positive and the y is positive. Quadrant 2 is right here on the left side. We are going counterclockwise for standard position. The x is negative, the y is positive. Quadrant 3, here the x is negative, the y is negative. In quadrant 4, the x is positive, the y is negative. Now this is going to be our 0 degrees or 360 degrees. This is a 90-degree angle. This is 90 degrees. And then we have another 90-degree angle. So 90 plus 90 is 180. Plus another 90 is going to be 270. And then plus 90 gives me the 360. Now, keep in mind, we are traveling, starting here, going in this direction. All right. So for our first example, we are going to sketch some angles. We are going to sketch each angle in standard position. So 60 degrees. 60 degrees is between 0 and 90. And if you think about it, if you separate the 90 into 3 sections, it's about 2/3 of the way up. So here, this is going to be my 0 degrees. This is my 90 degrees. We are starting here on the x-axis. Now 60 is going to be about 2/3 of the way up. So that's going to be our 60 degrees. Next, let's try 210. So 210 is between 180 and 270. But 210 is just 30 more than the 180. So you're going to go 1/3 of the way between here. So here's the 0 degrees. Here's the 180, and then the 270s down here. We are starting on the x-axis. That is our initial side. And then 270, remember what I mean, 210 is between here, but it's closer to the 180. It's a third of the way down. So it's going like this. This is 210 degrees. If I asked you right here, what is the measurement from this side to this side? If this is 210 and that's 180, the difference between here would be 30 degrees. We will get into this later. This is called the reference angle, the shortest distance to the x-axis. On C, we have a negative 45 degrees. Now, the negative, that means instead of going the counterclockwise direction, you are going to go clockwise direction. So right here, this is going to be clockwise direction. Which means you're going to be wrapping around this way. So now, here, this would be a 0 degrees. Down here, this actually be a negative 90 degrees. So 45, negative 45 is between 0 and negative 90. So I'm going to still start here. However, I'm going to go this way. So that right there is negative 45 degrees. See if we get that one more. A negative 300. All right, negative 300. We're going to go counterclockwise again. I mean, go clockwise this time. So this is going to be 0 degrees. This is negative 90 degrees. This is going to be negative 180 degrees. This is going to be negative 270 degrees. And then this is going to be negative 360 again. So now we're almost making a full circle. We're going to start here, but now you're going to go to negative 300, which is between negative 270 and 300 and 360, I mean. So it's going to end somewhere right here. And you are going this way. And that's going to be the negative 300 degrees. And once again, what if I asked you what's the difference between here and here? So what degree is that? Well, think about it. If that's negative 300 and this is negative 360, the difference between 300 and 360 is going to be 60 degrees. Let's go on to coterminal angles. On coterminal angles, two angles in standard position are coterminal angles. If they have the same terminal side. Let's start off with like, say 135. Remember, this is 0 degrees, this is 90, this is 180. We're going to still start here. And 135 is somewhere in between here. Now, one full cycle is 360. So to find another coterminal, what I could do is I could take the 135 and I can add a 360 to make it basically go all around the circle and end at the same terminal side. So if I add 360, that would give me a theta of 495. So these two angles are coterminal, and this is what it's going to look like. It still starts here, and it's still going to end here. What's going to happen is it's going to hit it and then add a 360. So then it's going to go one full cycle around like this. That's going to be 495 degrees. Another way we can do this is we could take the 135 degrees and we can subtract the 360. So you're ending here, but if you subtract 360, you know, now go back this way. So if we do that, we get a negative 225 degrees. Well, think about it. This is 0 degrees. We are going negative, so this is going to be negative 90 degrees, negative 180 degrees, negative 270 degrees. So basically what ends up happening here is you just go to negative 225, which is between negative 180 and 270. So you still end on the same terminal side. These are called coterminal angles because they all end at the same angle. Now, reference angle. Reference angle is for an angle in standard position the reference angle is the acute angle formed between the terminal side of the angle and the x-axis. Better yet, the shortest distance to the x-axis. Shortest distance to the x-axis. Our reference angle will always be a positive also. Let's say this one goes to 135. 135 is somewhere right here. We'll say this one goes to 60. And then we'll say this one goes to negative 100. If it helps, write your angle. Since this is positive, this is a 0 degrees, this is a 90, this is a 180, this is 0 degrees, this is a 90. Now these are negatives because it's negative 100, so this is going to be a 0 degrees, a negative 90 degrees, a negative 180 degrees. If your terminal side is ending right here, and reference angle is the shortest distance to the x-axis, so I'm looking for this right here. It's always going to be a 90 degrees. I want the measurement of right here. So if I go 135, how much more to get to a 180? That's basically what I'm looking for. So this is all the way to 135, but I want to go shortest distance to x-axis. And if this is 180, 180 minus 135 is going to be a 45 degrees. And the way that we represent reference angle is like that. Right here, this is your x-axis. If you're ending here, you want the shortest distance to the x-axis, so that is straight down. Well, guess what? It happens to be the same exact measurement. So if that was 60, my reference angle is still going to be 60. This is my x-axis. So this is where I'm ending. I'm ending at a negative 100. Well, look, shortest distance to x-axis means I'm going to go up. So I need to know the difference between negative 100 and negative 180. And the difference between negative 100 and negative 180 is going to be an 80. Your reference angle is always going to be a positive number. And just know that the reference angle should be between 0 and 90. It should never be more than 90. Next, we're going to find the measure of an angle in standard position for each reference angle. So here we have 10 degrees and we want it in quadrant 3. On B, we want 42 degrees in quadrant 4. So quadrant 3, here's quadrant 1, here's quadrant 2, here's quadrant 3. So basically what's happening is we're starting here. Reference angle is the shortest distance to the x-axis. So here's the x-axis. I want to end somewhere in here, but I only want to end 10 degrees more. So I'm basically going to put a 10 degrees right here. Well, from here to here, this is 180 degrees. So I have to take the 180 and I have to add the 10. So 10 degrees plus 180 degrees. This answer is 190 degrees. Here we have quadrant 4. Quadrant 4 is down here. Now, we're starting here, and because it's 42, it's 42 away from the x-axis. So right here, this is going to be a 42. Now, this is going clockwise. So that's just not a positive 42. It's actually negative 42 when I'm considering it. So since all of this is 360, I'm going to take the 42 degrees because I'm going clockwise. So the answer here comes out to be 318 degrees. Next, we're going to go into radian measurement. A radian measure is the ratio of the length of an intercept, an intercepted arc, and the radius. An angle measure of 1 radian subtends an arc on the unit circle with length 1. Now the unit circle has a radius of 1. That's why it's called a unit circle. And its center is at the origin 0, 0. So for example, this is our x-axis, this is our y-axis. I'm going to go to -1, +1, +1, -1. The unit circle has a radius of 1. That's the unit circle. Now, keep in mind, if we were talking about the circumference of a circle, the circumference is equal to 2 pi r. And in this case, our radius equals 1. So the circumference is equal to 2 pi times 1, which is just going to be a 2 pi. So when we're talking about our unit circle, the distance all the way around is equal to 2 pi. Well, we also know that around a whole circle, that's 360 degrees. Hence, that the radians can be equal to the degree. Now on the radians, that's a 2 pi. On the degrees, the same measurement around is also 360. So if we're going to convert these, basically if I divide both sides by 2, pi is equal to 180 degrees. So if that's the case, when we're talking about our unit circle, this is my x-axis, this is my y-axis. So where 0 is at, that's going to be 0. Where 180 is at, which is right here, that's going to be pi. Well, if I take pi and I divide it by 2, up here, that's going to be pi halves. Well, think about it. That's 1 pi halves, 2 pi halves, which reduces, 3 pi halves down here. And then 4 pi halves is just going to be the same as 2 pi. And we already knew that 2 pi was equal to 360. So this is basically the conversion factor that you're using. This is the radian measurement. This is the degree measurement. So we're going to do some conversions. First, we're going to convert each radian measure to degree measure. Now, because you want to end with degrees, you want the degrees as the numerator, okay? Because we want to end with degrees. So basically what I'm going to do is I'm going to multiply. I want the degrees on the top and I want the radians on the denominator. So right here, what I'm going to do is I'm going to multiply. I want the radian on the bottom. The radian is going to be the pi and the degree is going to be the 180. So this is pi and this is going to be 180 degrees. My pi's are going to cancel. And then 3 times 180 divided by 2, that is equal to 270 degrees. I want the pi's to cancel. So pi goes in the denominator and pi is equivalent to 180 degrees. Right here, my pi's cancel and 4 times 180 divided by 3, that's equal to 240 degrees. So these are the same exact measurements. Let's go the other way around. We are now going to convert each degree measure to a radian measure. So here we have 135 degrees. Here we have 210 degrees. Now on this one, you want to end with the radians. So we need to cancel out the degrees. So here you're going to multiply. You want the degrees to be the denominator because we're canceling out the degrees. And I'm going to put radian in the numerator. I need to cancel out the degrees. So 180 goes on the bottom. And 180 is the same as pi in radians. So right here, 135 divided by 180, that's going to actually be 3 over 4 pi. And if you wanted to, you could say radians. I'm trying to get rid of the degrees, so I'm going to put 180 degrees in the denominator, pi is the numerator. 210 divided by 180, that's 3 over 2. So these are the same and these are the same. All right, last part of the notes has to do with arc length. Last part of the notes has to do with arc length. Now with arc length, it's the length of the intercepted arc of S. Now, S is going to equal to theta times the radius. So if this is my circle, this will be your theta. R is going to be the radius, and S is basically the circumference outside of that section. So S is going to be the arc length. So not the whole length of everything, it's just a specific section. Theta has to come from the central angle. So it has to come from the origin. But one thing about theta is it has to be in radians. So if the problem gives it to you in degrees, you need to change it. And we just learned how to change it. 180 is equal to pi. And then R is equal to the radius. So second to the last example, we need to find the arc length for a theta of 45 degrees. Okay, do not plug in 45 degrees because I just finished telling you that it needs to be in radians. So I'm going to need to change that to radians. And a radius of 7 meters. So this is what the picture is going to look like. So my radius is 7 and my angle is 45. 45 is going to look like this. Now we know that S is equal to theta times R. You cannot plug in 45. I need to change that. Now I want to get rid of the degrees, so I'm going to put the degrees on the denominator. And 180 is the same as saying pi. 45 divided by 180, that's actually going to be 1/4 with pi in the numerator. This is going to be the radians. So that's what's going to get plugged into here. And you don't need to put 1/4. You could just make it equal to pi/4. That's the same thing. So S is going to be pi/4 times the radius, and the radius is 7. So S is going to equal 7 pi/4 meters. And if you type that in the calculator, that is approximately 5.498 meters. So that one was pretty straightforward besides it giving you degrees. Last problem. The radius of Earth is 64,000 kilometers. A satellite orbits the Earth, at 320. Above its surface, that's key right there, it's above the surface. What distance does the satellite travel if it orbits through a pi/6 angle? So they gave me the radian measurement. Let's draw a picture what this looks like. So here's the Earth. And the Earth is 6,400. So from here to the end, this is 6,400. The angle is going to be pi/6. So let's draw pi/6. Now above the Earth, it's going to be another 320. And now the satellite's orbiting around it. Let's draw that with dashed lines. This is the satellite. So if S is equal to theta R, the theta is going to be the pi/6. Now the R is going to be the 6,400 plus the 320. So the satellite is going to be pi/6, 6,720. And if I divide that by 6 and multiply that by pi, I end up getting approximately 3,518.58. And that concludes our notes.